Okay, so the first question is asking, was your dropping height larger than the height of the first hill? Why do you think this was the case? I said yes, the dropping height at the beginning of our roller coaster was larger than the second hill because the ball needs to gradually increase its velocity to go over the first hill. The GPE has to be the highest at that point. So basically what I'm trying to say is at the beginning of our roller coaster, our dropping height has to be larger than the height of the first hill because if it's not larger, then the marble will not gain enough velocity to be able to go over the first hill and therefore complete the rest of the roller coaster. Okay, the second question is asking me to describe the mechanical energy of the coaster that occurred or will occur for your marble to complete the coaster course you designed. So basically, the law of conservation of energy tells us that energy cannot be created or destroyed. It can only change form. So, the mechanical energy is basically the total energy in the system, which is in this case the roller coaster. Mechanical energy, so total energy, can be seen at the highest point of the roller coaster, which is usually at the beginning. The number that you get when you calculate the total mechanical energy tells you how much energy, so total energy, the marble will need to complete the system. So basically what this is saying is mechanical energy has to be the highest at the beginning of the roller coaster. So basically when at the beginning of the roller coaster, when you have the marble like ready to drop, that moment, like that position is where the mechanical energy is going to be the highest. So basically that is where it's telling you how much energy is needed for the marble to be able to complete the roller coaster. My third question is asking, other than kinetic and potential, what other types of energies are present throughout your roller coaster? So I said another type of energy shown can be thermal energy, which is energy due to the heat of a system or object. Energy can be converted to heat through frictional dissipation. So frictional dissipation is basically a phenomenon in which mechanically useful energy, such as the motion of the roller coaster, is converted to mechanically useless energy, such as heat or sound. So friction acts on all moving objects, and it is the reason that, in this case, the marble rolled, let's say, down the hill. So my fourth question is asking, how does the height of each interval impact the values of kinetic and potential energy? So potential energy and kinetic energy can be exchanged for one another. At certain points on the roller coaster, the marble may have just potential or kinetic energy, and at other points it may have both. So, for example, at the top of the first hill, the gravitational potential energy is always the greatest, which is the maximum energy that the marble will have throughout the roller coaster. So that energy can then become kinetic as it travels towards the bottom of the hill. So if a taller hill was placed in the middle of the roller coaster system, then the ball or the marble could not complete the roller coaster. So my last and final question is asking me to describe the conservation of energy, including potential and kinetic energy transformations throughout my roller coaster, using words in a label diagram. So the beginning of the roller coaster usually demonstrates the total mechanical energy needed to allow the marble to complete the roller coaster. Besides this, the gravitational potential energy in the system is usually seen alone at the highest part of the hill due to how the velocity is zero or almost zero. As the marble begins traveling, the gravitational potential energy starts to decrease, and the kinetic energy that was originally at zero at the bottom of the hill begins to increase. So once the marble reaches the bottom of the hill, the kinetic energy is seen as at its highest. So the conservation of energy states that energy can be made or destroyed, but can't change form. So on a roller coaster, energy changes from potential to kinetic and back again many times over the course of the ride.